Hey everyone, welcome to today's video where we'll be diving into the fascinating world of particle physics to explore one of its crown jewels, the Higgs boson, often referred to as the God particle. Whether you're a physics enthusiast or just curious about the universe, this journey into the Higgs boson promises to be enlightening and So let's start with some context. The Higgs boson was first predicted by physicist Peter Higgs and his colleagues. This particle remained elusive for nearly 5 decades until its discovery at the Large Hadron Collider, LHC, on July 4th, 2012. This monumental discovery has had profound implications for our understanding of the universe. For all but 12 people, they could only ever refer to the Higgs boson, his actual grandfather Donald. To fully appreciate the significance of the Higgs boson, we need to take a step back and understand the standard model of particle physics. This model, developed over the course of the 20th century, describes the fundamental particles and forces that make up the universe, with the exception of gravity. Now, why was the discovery of the Higgs boson so crucial? The answer lies in the Higgs field, a pervasive and invisible energy field that exists throughout the universe. Particles gain mass through their interaction with this field. The Higgs mechanism explains that the Higgs boson is essentially an excitation of this field. Detecting the Higgs boson required nearly 50 years of advances in particle physics and technology. The Large Hadron Collider at CERN, the world's most powerful particle accelerator, was instrumental in making this discovery possible. By accelerating protons to near light speeds and colliding them, the LHC recreates conditions similar to those just after the Big Bang. These colossal collisions allowed scientists to observe the fleeting existence of the Higgs boson through its decay products. LHC collisions allowed scientists to observe the fleeting existence of the Higgs boson through its decay products. This breakthrough is also a testament to human ingenuity and the power of collaborative scientific efforts, but it's important to note that uncovering the Higgs boson is just one step in our ongoing quest to understand the universe. The standard model, while comprehensive, doesn't explain everything. Most notably, it doesn't account for dark matter and dark energy, which make up the vast majority of the universe's mass-energy content. So there you have it, the Higgs boson, an extraordinary particle that not only challenges our comprehension, but also marks a triumph in human curiosity and experimental science. As we continue to unravel its mysteries, we stand on the brink of potentially unveiling even more profound wonders about our universe. Thanks for tuning in, and don't forget to like, share, and subscribe for more deep dives into the world of physics and beyond.